Friends and friends, welcome to my YouTube channel. Today I am going to discuss the friction problems. So inclined body friction problems. So my YouTube channel is Dr. Ashok G Make Solution. So those are new with my channels, you subscribe the channel and you will watch the different subject solutions and concept I given. So here this questions frictions this question belongs to the friction. So what is the questions given here? An effort of 200 Newton is required to move a body upon inclined plane at angle 15 degree. So first one, case 1. What is case 1 the given? I will draw the diagram. So what is given questions, diagrams I have to draw. So one inclined plane, angle of 15 degree. I made the 15 degree, one plane will be there. This angle given 15 degree and the force acting parallel to the plane. How much force? This 200 newtons acting parallel to the plane. So parallel to the plane. How you know the parallel to the plane? Suppose inclined body plane, how will move? Body will move this way. This way. That's why this force is nothing but parallel of the plane. How much given? 200 newton. 200 newton given. This is the diagram. This is differently will be the rough surface. This will be the definitely rough surface. Okay. The fourth one. If case 2, if the angle of inclination made by 20 degree. Now we will do the case 2. What is this? Angle of inclination will be 20 degree. So what will be this diagram? This is the given questions. We are drawing the diagram. This is the given plane. This is the given 230 Newton and this angle given 20 degree. This is given 20 degree. That effort required again parallel to the plane. So parallel to the plane, parallel to the plane. Now they are asking find the weight of the body and coefficient of friction. So both cases we need the weight. What is the, suppose inclination is 50. Now next case inclination will be 20 degree. Then what is the weight? What will be the coefficient of friction? So let us assume W be the weight and mu be the coefficient of friction. Coefficient of friction. W be the weight and mu is the coefficient of friction. So okay, now this is the given problem, given diagram. Now we'll draw the same diagram, free body diagram and free body diagram for both. So again we will go to draw the diagram, same diagram, and we'll draw the free body diagram. Once you know the free body diagram, our almost work will be over. 1 minute. So free body diagrams we are going to draw. So same diagram first we'll draw and incline 15 degree. Approximately we draw 15 degree, then weight and the block. We draw the block on the inclined plane. This angle is 15 degree. Okay, then effort required how much? 200 Newton given for this. Given 200 Newton. Now, this is the given. Now, free body diagram means everything we have to show this what is existing. Suppose weight is there. So weight always will act vertically downward. This is the center. Suppose weight will be act vertically downward. This will be the W. But normal reactions along the plane. Normal reactions along the plane. So this is the normal reaction. So we take the R. We take Suppose we are taking case 1 R1 R2, or you keep it R. So once we'll draw for case 1, then case 2, then we'll combine together. So you let us assume R only. Okay, now here once we draw this normal reactions along the body. So this angle will be again 15 degree only. So this will come W near angle cos component cos W cos 15 degree. Then this is the one resolution for this W. W is in weight. This is inclined plane having two components as we know. So this perpendicular, what will be the W sine 15 degree. So this over. Now we'll see the frictional force. Frictional force W sine theta and W sine 15 degree 200. So frictional force will be the opposite of the bigger forces. But here exact we don't know. But we are assuming 200 will be the bigger. So frictional force we are taking this direction. So frictional force we are taking this direction. If our directions once we are assumed is wrong, then you will get negative. So that time we'll write the change the direction of frictional force and we'll leave it. No need to solve again and again. So we draw here frictional force. Now next case 2. This is case 1. Case 1 diagram. So case 2 diagram. Case 2 diagrams we'll draw. So free body diagram now I'm going to draw for this ambula. So this is the inclination now 20 degree. Inclination is 20 degree. Just we'll assume this angle 20 degree, no need to measure and draw. Just 20 degree we wrote now, that is mathematics now, we can assume this is the 20 degree. So over. Now this is if what required along the plane. So 230 given here, 230 Newton, this is 200 Newton. 15 degree, then this is 20 degree. So 20 here similarly, weight will act vertically downward, the normal reactions along the body. So along the body once you draw now one resolutions I know. So this is nothing but this is suppose W, so W cos 20 degree, already told near angle always cos component. Now this resolutions 1, then perpendicular of this nothing but second resolution. So this is nothing but W sine 20 degree. W sine 20 degree. This is a normal reactions. Case 2 again R. We can write R1, R2, but okay R. Because any of that is going to cancel only. So 230 Newton. Now frictional force will be there. So frictional force, again we are seeing here W sine 20 is 230. So this, we are assuming 230 will be the bigger. So frictional force always opposite of the bigger forces. This is the concept. Friction force always opposite to the bigger forces. This is the concept. So this is the free body diagram now we draw. So this make it the rough surface. This surface is rough only because we are studying static friction. Surface will be rough. So now we know these two. Now what we have to do? In both cases, we'll apply the equilibrium equations, then we'll solve the W and mu. So see here, case 1, what is equilibrium equation first, sigma h equal to 0. That means what I told along the body. So just we are assuming here, rightward force, leftward force equal to rightward force. So what is this force here? F plus W sine 15 degree equal to 200. Now F equal to mu R plus W sine 15, how much? We calculated W sine 15. We not calculated, leave it like this, okay. So W, F equal to mu R, W sine 15 degree is equal to 200. Give the equations number 1. Now second equilibrium equations, what is sigma FB equal to 0. So that means total upward force equal to total downward force. What is going on? R. So R is equal to W cos 15 degree. W cos 15 degree. Now substitute R in equation 1. Substitute R in equation 1. So what we'll get? Mu W cos 15 degree plus W cos 15 degree plus W sin 15 degree. Are you correct? So sigma FH F plus W sin 15 degree is equal to 200. Sigma FB total upward to downward R is equal to W cos 15 degree. Now substitute this equation. So equal to how much here? 200. Equal to 200. So both W is there. Both places W is there. If we take the W common here, what we'll get here? Mu cos 15 degree plus sin 15 degree is equal to 200. Give the equations number 2. So case 1 over. Now we'll go the case 2. Now we'll go the case 2. Case 2. Similar things will apply here. Two equilibrium equations. Sigma H is equal to 0. So that means total leftward force equal to total rightward force. What is there here? F plus W sin 20. W sin 20 is equal to 230. So we can write here F equal to mu R plus W sin 20 degree is equal to 230. This gives equations number 3. Give equation number 3. Now apply another equilibrium equation. So total upward force equal to total downward force. What is there? R is equal to W cos 20. So if frictions, simple inclination force problem you solved, everywhere the same concept will be there. Both equilibrium equations. Now substitute R in equation 3. So what is there? Mu W cos 20 plus W sin 20 equal to 230. Now take the W common. Mu cos 20 plus sin 20, W I taken common is equal to 230. Give the equations number 3 and this is 4. Equations number 4. Equations number 4. So both equilibrium equations be applied here. So now we'll solve only, we'll get the answer. So what is equations 1 coming? Sin 15 plus mu cos 15, correct, 200. Then W sin 20, W cos 20, 230. Okay, now we'll divide 4 by 5. So see here, now how to solve. Divide equations 4 to equation 3. So divide equations 4 to equation 3. 3 is like 2. This is 2, equations 2. So 4 what is? 230 by 200 is equal to 230 now how much? W mu cos 20 plus sin 20 divided by W mu cos 15 degree plus sin 15 degree. W get cancelled. So 230 by this how much coming? So this calculations like that, how much is the calculator? Calculator nikalo back sir. So now see here, we'll solve, then we'll go the cross multiplication. So 230 by 200. We'll see how much coming. 230 divided by 200. It's coming 1.15. 1.15 divided by 1 is equal to mu cos 20 plus sin 20 divided by mu cos 15 plus sin 15 degree. Whatever there we wrote. Now we'll go the cross multiplication. Cross multiplication na, suppose A by B is equal to C by D. Cross multiplication na AD into equal to BC. So we'll go the cross multiplication, this and this. So what we'll write here? 1.15 mu cos 15 degree plus sine 15 degree is equal to 1 into this one, mu cos 20 degree plus sine 20 degree. So this we can cross multiplications we did. Now we have to do multiplication, this into this into this, and 1 this. So then mu will bring this same side. So what will get the final answer I will write now. So you have to do that calculation. So if we will see the mu, here mu you will get 0.25. This will get the mu. Now if you mu substitute either equation 2 or equation 3. Substitute mu either equations 2 or equations 4. You will get the W. 293.7 Newton. So this way you can get the answer. So now you see here, like this big question, how to solve. Given diagram, given problems, draw the diagram. Then draw the free body diagram. Apply the two equilibrium equations. Comparison is there, no? 200 if Newton effort required, no, 15 degree. If inclination will increase, suppose inclination is increasing, gradually increasing, effort difference will be more. So that is the given. So 20 degree effort will be more. In that cases, what is the weight of this body and what is the coefficient of friction? So both we got here. These both are the answer here. Okay. So okay students, simple concept. You just watch this video, note down this all the problems step wise, and study this way. Okay, and share this video to your friends. Subscribe the channels. Okay, thank you.